What's up guys, Pete here, and welcome back to Proto Productions. In today's episode, I want to explore a brand new technique to me and see if it can't breathe some new life into an old project of mine. Lately I've been seeing a lot of really cool content centered around casting different things into 3D printed molds. And the two main things that have caught my eye is the use of either cast concrete or cement, and the second is something called epoxy granite. The concrete side of things is pretty self-explanatory, but the epoxy granite needs a little more explaining. But essentially what you do is that you take normal traditional casting resins, and instead of mixing in things like mica powder or glitter, you mix in a large proportion of things like sand and stones and gravel, and this forms kind of like an epoxy concrete in some ways. This is why they call it epoxy granite. And it's really, really useful for things like machine castings because it's really good at damping, really good at deadening vibrations, and it obviously just adds a lot more mass into what would otherwise be a fairly light substance like epoxy. Both of these techniques, the concrete and the epoxy granite, sound really interesting to me, but I don't really have a need for like a large machine casting right now, which is what most of these tools are used for. So I wanted to find a smaller project so that I could kind of debug the process a little while still getting something useful out of it instead of just doing a bunch of like material samples. I was looking around on my desk and what I found was an old project that I'd done years ago, this little pen organizer here. It's fairly simplistic as far as designs go. It's just a cool hexagonal design for the top, and then for the base, there's just a simple 608 skateboard bearing pressed into the bottom so that we're able to get that kind of fun free spinning motion to it. This was built literally just with some scraps that I had lying around in college, and while I'm pretty happy with how it turned out overall, there's definitely some room for improvement here. The upper portion of the design up here where it actually holds all the pens, and in this case a lot of Allen keys, honestly works pretty much fine. I don't really have any major revisions that I'd like to make up there. Where I do have some issues though is in the actual base of this part. See, the problem that I have, besides just kind of using the wrong bearing setup here, this is a fairly lightweight and fairly shallow base, and it means that it's pretty tippy, especially if I had anything heavier in here. For a while I was keeping a couple sets of like scissors in here, and that just was not going to work. Pretty much, even as it sits currently, if you start spinning it, you can see it really likes to lean towards the heavy side, and it's pretty prone to tipping over. So this seemed like a perfect project to try out these new techniques because it would really benefit from a much heavier base down here, something cast out of either concrete or an epoxy granite type situation. I don't have any concrete or cement lying around, but I do have plenty of epoxy. I've got some deep pore resins, I've got some tabletop resins, I've got some UV resins, plenty of things to experiment with. But resin alone isn't going to be heavy enough to really solve this problem for me, so I am going to want to go more in that epoxy granite situation where I'm adding in some type of heavier substrate. Now normally this would be things like sand or stone or gravel, but I don't really have any of that readily on hand and I don't feel like just digging up my yard at the moment. But what I do have is admittedly a little weird, but should work pretty well. This is 17.4 pH stainless steel powder. Now, in my day job, I work with metal 3D printers, and that means that I have access to an abundance of our waste powder. This is metal powder that's used for metal 3D printing that just no longer meets the quality standards that we need to put into the machines. It's maybe contaminated with dust or grit from the air, or in this case, it's likely just the wrong particle size or particle distribution for us, so it's kind of useless for me as far as 3D printing goes, but I think we can give it a second life. This particular powder is super, super fine, so I think it should mix in really well to whatever resin that I use. And in addition to that, it's like twice as heavy as cement, so I think we should get a pretty good weight out of our final part. The other cool thing about using metal powder like this is a technique called cold casting. So in the realm of just normal epoxy resin casting, something you can do is you can take a very fine powder like steel powder, brass, bronze, any metal powder that you might be able to get your hands on, and you can brush on a very thin coating into your actual mold, and then when you cast your epoxy directly into that, you take your part out and you can actually buff that surface because it has a very thin coating of the metal powder in there. What that means is you get that nice, bright, shiny, actual metallic surface without having to actually fill the part full of metal. Now, this isn't the first time I've had this thought. A few months back, I actually was first struck by this idea of kind of reusing this metal powder with resin, and so I did do one little test experiment just to see how it would go. This is a mixture of some random deep pore resin that I had lying around, as well as that metal powder, and already I've learned some really valuable things here. The first is that that metal is absolutely going to settle out of most resins. So you can kind of see here we have this very well-defined striation here. All of our metal has sunk right to the bottom of the cup, and we're left with a very, very thin layer at the top where there's basically no metal powder left. The other thing I've learned is that one, it is absolutely heavier than you would expect, which is exactly what I'm looking for, and two, that it's actually still fairly strong. I was a little worried that with how much this has settled out, this would be pretty brittle down here, but the end result is actually fairly tough, so I'm not that worried about using it for like an end-use application. And lastly, I did try a little bit with that cold casting technique where you kind of buff and polish the surface. And I'll get you some close-ups here, but I think it actually does turn out fairly nicely. You do get that nice kind of faux metal sheen to it that you can kind of buff to a higher luster, which is a pretty cool technique. While I learned a ton from this little test sample here, there's a bunch more that I need to learn before I go and tackle the full-size project. So I think part of this is going to be to go do some small-scale tests and see what we can find out. Right off the bat, a couple of things that I want to try is using a tabletop resin versus a deep pour resin. So tabletop resins are not meant to be poured in larger volumes, and because of that, if you do pour them in a larger quantity, like I'd need to cast something like this, they tend to have thermal runaway. So they're going to cure, generate some heat, that heat is going to cause it to cure faster, and that's just going to go and go and go until eventually the whole thing practically bursts into flames, typically ruining whatever you're working on. What I want to find out then is that if I can mix in enough metal powder, will it suck away enough of that heat that I don't need to worry about that and can use a resin that's going to cure much faster than like a deep pour resin. I also just need to figure out in general how much resin do I actually need per volume of metal powder. As you can see in this case, a lot of this resin just went to waste up at the top here, so there's definitely an optimal ratio I'm going to be hunting for. Now I do have some deep pour epoxies as well, so if the tabletop epoxy still doesn't work because it cures too quickly, I do have a couple of options for the deep pour side of things. The only downside there is that those take literally days to set up, and I'm pretty impatient when it comes to projects like this. The other issue you have is that because it takes so long to set up, the metal powder is almost definitely going to settle out of the solution by then, and that's going to end up again with a similar situation to what we have here. But something you can try with deep pour resins is that because they have such a long curing time, there's a spectrum of densities and viscosities as that resin is curing. So initially it's going to be fairly runny like water, and it's great for kind of degassing and getting it to mix thoroughly. And at the very end, obviously it's totally solid, but in between you have this weird middle state where it can be a little bit gummy, it can be kind of soft, it can be gooey, it can run like honey, and somewhere in there might be just the right ratio of density and viscosity where you can actually mix in your metal particles and they won't just immediately fall out of suspension. That might be a really cool way to not need to worry about this settling out problem, and we can still use our deep pour resins. We'll just have to suffer with the fact that it takes, 2 to 3 days to start setting up. Before we get to the resin tests though, I do think I want to go ahead and actually redesign my original part here, just so I get a sense of the volumes that I'm going to be working with and any little gotchas that might come up when it comes to design the actual molds. So I think our first step here is to head on into CAD and let's see what we can do for a redesign of this part. So I was actually able to find the original CAD model that I did for this, which is kind of neat. This is like over a decade ago at this point. And so we can actually see some of the differences between what I'd originally modeled here and what I ended up printing. One of the obvious things is that this is much, much taller than the design that I ended up going with. Honestly, I was probably just impatient and didn't want to wait for this whole thing to print. This was back in like the CR10 days of printing, so this is going to be a lot of printing. Other than that, there aren't too many other differences, except that I did end up going through and it looks like there was a washer I originally planned to have between the top and bottom, and I just completely omitted that. So pretty much we still have the pin that's pressed into the bottom here, and then we have the ball bearing that's pressed into the base down here, and that's pretty much all it is, nice and simple. So with that little history lesson, let's run over to the new model that I've put together here, and let's take a look at some of the differences. So one obvious thing, I've actually modeled the top portion to be the height that I plan on printing this at, so a fair bit shorter here. Then for the base down at the bottom, I've kind of just tweaked the geometry. I've made it a little bit more rounded off, a little more flowing, with an eye as well to relief and draft angles, because I do plan on casting this. I think it's also a little bit thicker, which should just give us a little more material in here and give us a little bit of extra weight. And then I have given a little more attention to how I actually want to secure these two things together and how that bearing is supposed to function in this case. So previously I used a pin. In this case, I'm actually going to use a screw in order to secure the bearing to the top portion right here and allow me to kind of set the tension as opposed to just dropping it and having the weight of the system do that. I've also been a little more intentional about what regions of the bearing are going to contact what components. So you can see that the upper portion of the organizer here only actually touches the inner race, and the inner race is only touching the screw down here, whereas the outer race is what's making contact with the lower section of the base here. This should hopefully minimize any rubbing that you would see if I just have this totally flat across, and so that's the point of this groove up here, so that the top portion doesn't rub against the outer race of the bearing. Other than that, it's a fairly straightforward design. I did mention I have some things in mind already because I know I'm going to be casting this, so all of these angles here help provide some draft angle, the same with the bottom of the base right here. But other than that, it's a pretty straightforward design, so I think we're going to go send this off to the printer and see how we like it. All right, let's take a look at our first little prototype parts here. Right off the machine, they're looking great. These weren't particularly challenging parts, so I wasn't particularly worried about it, but always nice to see that they came out looking as expected. Let's see, the real questions is going to be things like our bearing fit here, because I kind of guessed, nope, that is pretty much exactly where that needs to be. Sits in just about a millimeter below, or a millimeter above the surface there. And then we should be able to get this all bolted up here. I've got my 5/16 bolt, which is a perfect fit for an M8, by the way, if you have any lying around. Look at that. That's feeling pretty awesome. I think this is going to work out really well for us. I think that is, there we go, exactly what I was looking for. I think overall this is looking pretty good. Now that I'm happy with the prototype design that we've printed up here, let's head back into CAD and figure out what we're going to do to actually mold this bottom section, because I think we'll be able to get away with a pretty slick little open pore design. Okay, JK, I lied. Real quick before we jump back over to CAD. I did just take a closer look at this, and yeah, that wobble is entirely because of the bearing. I've got this screw tightened down pretty much as tight as it's going to go, and so the inner race is fully snug against our part as intended, but what's left is just the slop of, there you go, the bearing itself. This is a dirt cheap bearing, so I might just try to find a slightly better quality 608 bearing, but honestly, this is just not the right way to use a radial ball bearing like this. Really what we'll be wanting to do here is use a thrust bearing around the outside here and then clamp onto that. I don't have one of those lying around though, so we're going to make do with what we have. I think it'll still be fine, honestly. That little bit of wobble just gives it a little bit of character. All right, so I'm going to get started on these resin samples, and I'm going to have a respirator on the whole time because I'm going to be working with resin fumes plus really fine metal powder. So before I throw that on, let me try and outline the plan here. I'm going to be mixing my two different resins. I've got the tabletop down on the floor, and I've got the deep pour up here for now. We're going to mix the resins in their appropriate ratios first. That's what these larger cups are for. And then I've got these smaller little Dixie cups for doing different tests of different ratios of metal powder to resin. Originally, I was thinking I was going to do 1-to-1 as a starting point, resin to metal. But honestly, I think it's going to be way too much resin. So I've pre-prepared my Vibes cup. This is going to be entirely based off Vibes. We're going to have a pre-dosed amount of metal powder, and we're going to slowly add enough resin until I feel like it's done, and try to take some mental and maybe some physical notes on what that ratio looks like. And we're just going to kind of go from there and see if we can find a consistency that makes sense. I imagine I'm going to be shooting for some kind of pasty, almost peanut buttery, maybe honey type consistency, but we'll see how that shapes up. So without further ado, I'm going to throw on the respirator, and we will probably head into time-lapse mode unless something interesting happens, which, hopefully doesn't, but we'll see how it goes. I'm pretty much done at this point. I am going to be checking periodically on my tabletop resins. I've got the temperature gun here, and I can see that the larger volume is definitely creeping up. We're in the 90s here. The smaller control sample of it is, again, same temperature, even though it's such a small volume. The one with a ton of metal powder in it, relatively speaking, is all the way down at like 79. And the one with a little bit more, the 1-to-1 mix, we're up around 85. So still lower than our control temperature, but a little bit higher. So obviously the more resin you have in the mix, the hotter it's going to get. We're going to keep an eye on that and see if these actually do run away on us or if they stay okay. If this one does run away, I might need to just spread it out so it doesn't, catch fire in my room. That wouldn't be ideal. The deeper pour resins I'm not worried about at all. Those should be pretty much fine throughout the night. So I will check up on these guys in the morning, and I will see you guys in a couple of seconds. All right, I'm recording this on my phone because I just can't be bothered to get the proper camera out, but we are officially approaching the danger zone. And what I mean by that is we are sitting at a roasty toasty, look at the max down there, 200 degrees Fahrenheit. She's smoking. And if we look at even our smaller cup down here, similar $1.20. Let me see here. There we go, $1.35. So we're officially in the danger zone. I would say we have officially surpassed the thermal runaway of this material. I have moved us into some stainless steel bowls just because I don't feel like accidentally melting that cup and pouring it all over my desk. Probably won't start a fire. Probably. Update number 2. I'm very glad that I put this in the bowl because we're melting, boys. We are officially melting. Just check the temperature here. What are we working with? Oh yeah, 224, boys. All right, so this is why you don't mix large volumes of tabletop resin. It doesn't like it at all. Even our smaller cup here, hopefully this one will have started stabilizing. Yeah, 160, it's creeping. It's definitely past where it wants to be. It's not happy anymore. We will see if our metal powder does what we need it to, which if I look at this real quick, yeah, I think we're okay. About 90 there, and should be lower here, about 85. For comparison, just like the ambient room temp here, a little under 80. So I think this will end up working for us. Not that, but these. So here's a quick update for you guys before we have to run off to work here. So obviously, The two tabletops are rock solid. They have completely set up. Interestingly enough, the two tabletop resins for the metal mix are also totally set up. So that's an interesting finding right there. The deep pour resin, kind of as expected, has entered this, I don't know what to call it. It's kind of like when you have molten sugar, maybe like a very thin taffy kind of situation here. I think we're already past the point of where I'd be able to mix in more metal powder to this stage for like a late addition. I think the technique might work, but I think it's gonna have to be after maybe like 6 hours instead of after 12 hours kind of situation. These are just setting up nicely. I'm not too worried about them in general as far as the ones that already had the metal pre-mixed. But as far as the tabletop epoxies go, this isn't too bad. If I can keep the heat managed, I'm a little worried that as we start creeping up, it might melt whatever 3D printed molds I use. But I don't know. We're going to have to do some more experimenting, and I'll check on these after work and just kind of see where they're at. All right, let's talk a little bit about how I plan on doing the mold for this. So because I'm using stuff that I just have lying around, I don't have any silicone, unfortunately. It's all gone off, so I'm going to have to use the 3D print itself as the actual mold here, which should be fine, but is going to need some special considerations. I think what I'm going to do in this case is a single open pour style mold, so think just like a cup basically that you just pour your resin directly into. And if I hide my bearing here and show some of the mold, we can kind of see what I'm thinking about here. So this is a super simple open pour mold. There's just an open top. You just pour your resin directly into it, and it should be fairly straightforward. I've already designed the base to have good draft angles pretty much everywhere. The only thing I was a little concerned about was this section up here, though this should be angled enough that we shouldn't have to worry about that. And then I'm planning on doing something that might end up biting me, but if I bring this bearing back, I was thinking about how I wanted to actually cast this because the bearing obviously would prefer straight walls for that bearing seat, and that's just going to be a lot harder to do if I don't have a flexible mold that's going to be able to release from that cavity. So instead, I think I'm going to actually try and cast the bearing directly into the part, which may end up coming back to haunt me, but I think it should be pretty doable. I have some filleting wax that I have from some carbon fiber projects. It's basically like a really sticky, tacky wax that you'll use for different molding layups. You'll see that when we go to actually like do this molding portion. And I'm pretty sure I can use that to seal off any areas that I don't want the resin getting into. I can use it to seal the actual bearing race itself so none of the resin gets in there. And then I've designed this little plug that the screw will go through. It'll clamp down on the bearing, keep it in place. We'll pack all around that as well, a nice little fillet of the wax. And I think that should work pretty well for us. When all this is done and cast, I'm hoping this plug will be able to just pop right out. It is, again, tapered and drafted at 3 degrees, so I think this should self-release fairly easily. And then again, everything else on the outside of the mold here also has some draft angle to it, so I think it should just pop out pretty easily. Only time will tell though, so let's send this over to the printer and see what we end up with. All right, we got our mold fresh off the printer here, and after some fighting with the machine, it came out looking great. As you probably saw the first time I tried printing this, it did not go super well. That is just because of my machine. It does not like printing if the chamber temperature gets over about 48 degrees Celsius. I gotta figure out what's going on with that. But when I printed this a little bit faster, it came out perfect. So very happy with the mold itself. This is printed in ASA at 0.1 millimeter layer heights. That should mean that this sands relatively easily, which is good because I hate sanding, and this is probably gonna take a while. The other reason I printed this in ASA was because it should be much more temperature resistant than PLA. So if we do end up going with the tabletop resin, we saw that even with the metal powder in there, it still gets reasonably warm. So hopefully this would be more resistant and actually hold up to that heat if we end up going in that direction. Did notice a couple things that we'll have to be careful for here. So I have a small recess in here so that the bearing in the actual mold will sit above that top surface. The problem is that there's a pretty hefty fillet on the face of this bearing. So while it does sit in the recess, there's a lot of wiggle room there, and there's a fair bit of gap all the way around. So hopefully the filleting wax will be able to kind of patch that in and make sure it's totally watertight, or resin tight in this case. So that's just one area we're going to have to look out for. The other thing that I noticed is that the screws that I have chosen, I only have 2 sizes, unfortunately, as far as lengths go, and the size that I was going to use is just way too short. There's just not enough thread sticking out of there to actually thread into the mold itself, which means we're going to have to go with the longer screw. Unfortunately, as luck would have it, the longer screw is way too long. That's just not going to work for us. So I'm either going to have to prop this mold up on something so that that screw can stick out the bottom, or I'm going to have to maybe shorten the screw itself, or I could reprint this little plug portion here just to hold the head of the screw up high enough that we don't have a whole like half inch, 3/4 of an inch sticking out the end here. Not the end of the world, but is something I'll have to tweak to get this mold to work as intended. Those couple little quirks aside, we're pretty much ready to get started here, so I'm going to set up the time lapse and get sanding. I'm going to just sand up to 400 grit to start. I might go higher than that, but one, I just really don't want to. And two, it's probably not necessary. I'm probably going to end up sanding my final part anyway. So as long as I get rid of all these layer lines in here so the part doesn't key into the mold, I think we'll be good. So I'm going to go throw on some tunes or maybe a podcast, get the time lapse going, and enter sanding mania. So I'll catch you guys at the end. All right, so the sanding portion is done and we're on to the next step of mold prep here. I've already gone ahead and sanded this all up to about 400 grit, and I think it's going to be good enough for what we're doing here. I've also gone ahead and sprayed both our main mold and our plug here with a mold release. Now the only stuff that I have on hand is this high build wax release, which is honestly actually probably well suited for this. It builds up a much thicker coating of mold release, which considering we're doing a rigid resin in a rigid mold, should help a ton for actually getting our part out of there. It also means that if I have any layer lines left on any of this stuff, it should fill those over fairly evenly and make sure we don't have to worry about our part actually locking into the mold. I've also gone ahead and degreased the outside of our bearing here, just wiped it down with some isopropyl alcohol so that hopefully the resin actually adheres well to the outside of our bearing race here, but there is a little bit more mold prep that we have to do. This is called filleting wax. It's basically a really sticky, soft, tacky wax that you'll use as a filleting tool to kind of bridge edges and fill gaps in a material that you know the resin isn't going to stick to. And we're going to be needing this pretty critically to protect both our bearing and to make sure we can pull our plug out later. So you can see that I've got a small recess down at the bottom here, and that's where our bearing is actually going to seat into. But obviously the fit of the bearing into there is not going to be good enough to keep the resin from spilling out. So what we're going to do is we're going to pack some filleting wax down into the bottom of that cavity there, and we're going to press our bearing on top of that, and then this plug similarly is going to get some filleting wax on the top of the bearing, and we're going to squish and screw that plug down, and hopefully that should seal everything in for us. Now this is going to be a little tricky because I have to kind of work with the mold and try to get that filleting wax down in here without scraping off all of the mold release that I've applied to the rest of this mold. So this is going to be a little tricky, but I'm going to do my best here. I don't really have any good tools for working with this stuff, and I might actually take the gloves off as well because these are probably going to be more trouble than it's worth for right now. So at least while we're working with the wax, we'll take the gloves off. Basically, we're just going to roll some little wax tubes here, and we're going to try and loop this around our plug. Make sure you can actually see what we're doing here. I'm just going to try and loop this around the bottom of our plug here. And the goal here is to have this smush out when we actually push it down. So I don't mind if there's some excess. I can clean that off later. But I need to make sure there's enough that it forms a good seal on top of that bearing race. Because if I get resin down in there, it's game over. There's no going back if we do that. So, all right, we're going to flip that over. And just set that right in there. Push it down. Okay. It's schmooing out as expected. Got a little shimmy to get it to seat there. Okay, it's looking pretty good. You can see it's squished out pretty nicely around the edges there. Now we're going to take our stud here, our little plug, very carefully try to, without scraping off too much of the mold release, get that situated and push down. Okay, it's looking good so far. Very carefully try and actually screw this down. Okay, let's see how that's looking. Got a little wax plug in the bottom there. That feels pretty solid. That's a good start. So you can see you've got that little ring of wax all peeled up around the outside there. And basically we're going to go through and just try and clean this up. Not going to go too crazy because we don't want to accidentally scrape off all the mold release down to the bottom here. But I do want to kind of clean this up, maybe give it a nice little fillet and blend it into the edges here, just so we don't end up with all that gunk in our actual mold. And I am going to go back in. You can see we've kind of peeled it up out of this race here. And the problem is resin is absolutely going to seep down in here. So we still need to have wax on this surface. We just don't want this much wax. So we're going to try and kind of push that back in like so. Okay. Not pretty, but I think that'll do. So that should be all of the actual mold prep that we need to do. We've got our mold release on our main mold here. We have it on the plug. We've got our filleting wax between the bearing and the bottom, between the plug and the bearing. Screws clamping everything down, so hopefully that shouldn't go anywhere. So I think our mold itself is ready to go, and we can move on to the resin portion. Okay, now as far as resin selection goes, I've let all of these samples cure for about 3 or 4 days at this point, so they should be pretty much fully set up. And while I technically think any of them would work, the deep pour or the tabletop resin, the fact that that tabletop resin did end up getting kind of toasty has me a little worried. It certainly was cooler, but we're going to be pouring a little more volume than we did before. So I think I'm going to play it safe and just have to sit for a little bit longer and let the resin cure for a few days. And we're going to go with the deep pour resin instead. And looking at the couple of samples that I have here, they both turned out more or less the same. The one that was exactly 1-to-1 definitely has a tiny bit more separation right at the top there. You're probably not going to be able to see that, but there's a tiny thin clear layer that you can see through before you get down to the metal portion, but it's not enough separation to be an issue, and again, this is going to end up being on the bottom portion of the base, so I don't really care. That said, I will try and mix it closer to my the Vibe mix, where it's closer to like a 9-to-10 ratio with a little more metal powder than resin, but if I don't get it exactly right, it's not the end of the world. All right, so I've got my resin pre-portioned out here. I'm just going to run through this before I throw the respirator on and the audio gets terrible. I've got my deep pour resin pre-portioned. I have my final mixing cup that I'll put everything together in, and I've also got our metal powder pre-dosed as well. Everything is a little more than we should need for the actual mold because it's always better to have too much than too little, especially since we don't have to worry about working time for this particular resin. So I've got everything set up. Let me throw on my respirator and then we'll get stirring. I'll bring in the mold, we'll do our pour, and fingers crossed, everything should go hopefully according to plan, but we'll see. I think that's about what we're looking for here. Do have a couple little areas that I'm a little worried might be dry spots and not just bubbles, but I'm not too worried about that. I think they'll saturate out over the course of the next few days here, so I think that's going to work for us. Let me go get the mold. We'll get that set up. So, here's the moment of truth. Firstly, we're going to try not to make a mess, and secondly, we're going to try not to overfill the mold. That's going to probably prove to be challenging, but we're going to do our best here. So I'll just start pouring. That is incredibly satisfying. It really does look a lot like cement, actually. Okay. I can tell we're not level. I can also tell I don't have quite enough resin, but I think I'm going to be okay with that. I'm going to end up having to sand the bottom of this off anyway, so I'm not too worried about that. I am a little worried about it not being level, though. Okay. That's pretty good, honestly. I think we're okay there. I'm not going to know if this is leaking until it's too late, basically, so there's that. Oh, shoot. Okay, real quick. So I've made a tiny miscalculation. When I was looking at the mold again, I realized I might end up with an issue where I can't get this part out of the mold. There's plenty of draft angle, but there's no way to really put pressure on the mold itself to pull it out of, or sorry, on the part itself to pull it out of the mold. And so what I was going to do was embed a couple of screws like this, just in a couple of spots after the mold got a little bit tackier, so that I could use those to basically yank the final part out of this mold. The problem is these have some amount of volume to them, and I have filled this pretty darn near to the top, so that might be an issue. The plan is basically, once this sets up a little bit more, I'm going to build a little frame, and I'm going to set these in just just barely below the surface. But unfortunately, there's probably too much material in here to do that. So I have some thinking to do here. Fortunately, I've got a fair bit of working time before this becomes a real problem. I can pull some resin back out of here if I need to, and this should still self-level fairly easily. So I've got some time to think, which I guess I'm going to have to start doing right now. Okay, so I thought I was recording. Turns out I'm not. That's fine. You didn't miss much. I 3D printed a little frame here to hold these two screws at a set height so that they're just held directly in the resin but not touching the bottom of the mold here. There was a small chance that potentially the whole thing could overflow when these two screws went in, but there really wasn't much extra volume from the screws, and there's a fair bit of extra height on this lip here, so we ended up being totally fine. This should be good to go, and I've got a little slot in the side here so I can pull this whole frame out when I'm done. So if I do need to get up under here and actually hold onto those screws to yank this whole part out of the mold, we can do that. But hopefully we shouldn't have any issues here. This should just set up over the course of the next 2 to 3 days. We'll check on it in the morning, but after about 3 days, this should be solid enough to demold, and fingers crossed, we should be able to pop this out without any chaos. All right, so it's been about 3 days, which should be plenty of time for this part to have set up properly for us to try and demold it. This is probably going to be a little challenging. Again, it's a rigid part in a rigid mold, and while I've done a little bit of planning for that, I probably haven't done enough. So I imagine this is going to get a little destructive, which I never planned on this mold being reusable, so honestly, I'm okay with that. That being said, if I can get a nice clean release from the mold, that would be both very satisfying and useful because it means I could try and reuse this mold in the future. Although honestly, knowing what I know now, I'd probably go back and redesign it anyway. Right away, we're off to a great start. I made this little frame here just to hold these screws in place while the resin was curing, and I intelligently left myself some slots here so that I could just slide the frame out of the way when everything was set up and it was time to take all this off. The keen-eyed among you will have noticed I did not leave a slot where that center stud is. Okay. Okay. Good news and bad news, guys. Good news. It totally popped right out of the mold. Bad news. You didn't get to see any of it. So, first of all, whoops. Second of all, sorry, but not sorry, because that... you can't make this stuff up. Okay, well, looks like mold release worked a treat. Came right out with just some minor percussive maintenance and only a little bit of edge damage here. Okay, well, you know, that's how things go, best laid plans and all that. So that was the first step that I was honestly most worried about. The rest of this honestly shouldn't be too bad. So let's try and get this center stud out of here and just see how that does for us here. This should, well, see, that's the problem. I don't really have anything to unscrew this from anymore. It does spin freely, so that's a good sign. So I should be able to just kind of, there we go, pop that right out. Is that enough clearance to pop this over? It is not. Okay, so let's see if these screws will come out. This is the other thing I wasn't 100% certain about, but let's see here. Oh, perfect. These are coming right out. I was definitely a little worried about that, but I think we're going to be good. Okay. That's the first screw out. And again, these holes you're never going to see. They're going to be on the bottom side of the part anyway. And in addition to that, I will probably end up putting a piece of rubber or felt under here, so you'll never notice any of these little imperfections on the bottom side here. All right, just like that. Got the two screws out. We got the central stud out. Now we just got to get this little post out of here. And I'm not entirely sure how I'm going to do that. So let me get some pliers and we'll see how we can tackle this. All right, got some needle nose pliers here. We'll see if this works. If it doesn't, I also have the option of potentially going in and threading a screw in there. Nope, perfect, came right out. Awesome, love to see that. I mean, that's pretty much it, guys. That came out about as well as I could have asked for. We do have a little bit of a lip where the resin is kind of climbed up the edges of the screws, as well as that central stud right there. Really not too worried about that. That should sand off pretty easily. Let me get this cleaned up, and we'll come back when I've got everything set up to give this a try on the base. All right, so we got our final part here all cleaned up. Overall, I'm really happy with how this turned out, especially for her first attempt on this. There were a couple of things. So on the back side here, I did flat this out with some sandpaper on my surface plate here, just because there were some high spots around our center stud here, the screws, and around the edges of the mold. So just went through and sanded that back. I'm not gonna go crazy because I'm probably gonna cover this all with maybe felt or leather or rubber feet or something. So I'm not gonna worry too much about it, but this sanded super, super quickly, and now this sits nice and flat on the table. And really the only issue that I can find with this whole thing, everything is pretty much perfect. There aren't even that many voids in this. Really the only issue is that, and you're probably not even gonna be able to see this, but the bearing is not perfectly flush with this top surface. It's in there just a little crooked. It's not a huge deal, but you might notice it when we actually screw on this much taller portion up here. Either way, again, for a first try, I'm super, super happy with that. So without further ado, let's get this all assembled here and see how we like it. We've got our screw that just goes in through the back side here. Get our top portion. Now this is the exact same one that I used for my mock-up. I might go back and reprint this either in a different color or I might tweak the design a little bit, but for now I think this will be perfect for a proof of concept. Oh yeah, that's so much more heft than before. Okay, so this is what I was a little worried about. Because that bearing is a little canted over, we are touching right on the bottom edge of the top portion right here. So for now, we're just gonna back that screw off a tiny bit, let it run a little bit more freely. I'll be honest, again, for a first attempt, I'm incredibly happy with that. All right, hold on, stop the presses. We found a solution. Check this out. Much better. And all it took was a humble washer. The very same washer that I was originally planning on putting in the old one gives us just enough clearance that we don't have to worry about it bottoming out anymore. I will probably need to grab a slightly longer screw now because of that, but functionally it works as intended, and it only took a minor tweak. So now I really am incredibly happy with how this turned out. Even with the small little issues we had on the base here, I think there's a lot of room for potential with this technique in general and for this overall design. So I think I'll definitely be revisiting this in my own time. Be sure to check out Instagram to see if we have any updates there, because I think we can do some pretty cool stuff with this. So there you have it, guys, the version that I made almost a decade ago and my brand new version made with some pretty cool new techniques. This was a great opportunity to breathe some new life into an old project and learn some new tricks along the way. I'm really happy with how this whole project came out, and I'm especially excited to see what we can do with that resin casting technique. I've already got some ideas for projects churning in the back of my head, but obviously if you guys think of anything, please let me know and we might just give it a try. This was a blast to work with, and I think there's a ton of potential here. So as always, guys, thanks again for watching, and I'll see you in the next one.